Welcome to this VxFlex OS demonstration lab. The following demonstration will show how to deploy VxFlex OS 2.6 in CentOS 7 and present volumes to Linux and Windows hosts. We will also explain how to throttle IOPS and bandwidth for a specific volume, and we will simulate a device failure and see how the system reacts with rebuilds and rebalances. For this demonstration, we will be using a mobile converged system which consists of 4 individual Intel NUCs, each having 32 gigs of RAM and dual SSDs, 1 gigabit Ethernet switch, 1 internal UPS, and 1 front panel connectivities for USB, HDMI, and Ethernet. First, let's prepare our CSV file that will contain basic configurations for our deployment. This file will be used in the VxFlex OS installer in the next steps. Next, we're going to install the VxFlex OS gateway on our Windows server to enable automatic deployment of our VxFlex OS on our 3 Linux hosts. We will also need the VxFlex GUI to monitor and manage the system. Once those 2 softwares are installed, open a browser and connect to the local host. Enter credentials for the admin user when prompted. Click on Get Started. In this step, you will need to provide the RPM files needed for the installation on the Linux hosts. Click on Browse, open the Red Hat folder, select all 9 RPM files. Now click Upload. At the bottom of the page, click Proceed to install. Now click on Browse to select the CSV file containing our deployment parameters. Choose New Passwords for MDM and LIA components. Review parameters. As you can see here, the MDM is configured in a redundant cluster mode on 3 hosts, with 1 master, 1 slave, and 1 tiebreaker. The MDM is the manager portion of the VxFlex OS system. Next, the SDSs will be installed on all servers contributing storage devices to the Scale.io system. The SDS manages the capacity of a single server and acts as a backend for data access. The SDC will be installed manually later in this video. The SDC is a device driver installed on each host that requires access to the VxFlex OS volumes. Start the installation when ready. The installation will only take a few minutes. When done, close the browser and open up the VxFlex OS GUI. Now let's create 2 volumes. One will be made available on a Linux host and the other one on a Windows host. Before we can present the volume to a host, we need to install a special driver on it. Once complete, you will need to configure the SDC to register itself on the MDM. Open a DOS prompt, run the driver configuration tool, and provide the MDM virtual IP. Time to map that 32 gig volume to the Windows host. Returning to the Windows host, we can see a new disk is available for use. Let's put it online, initialize it, and format it. The volume is now accessible as a drive letter E on the server. Now let's install the SDC driver on a Linux host and configure it to register itself using the MDM virtual IP address. Here in the GUI, we can see both SDCs properly registered. Time to map that second volume to the Linux host. The volume is now available on that host. Let's now generate some IOs on that volume. The dashboard shows current IOs and bandwidth usage. Let's see now how we can change bandwidth and IOPS for that volume in real time. Let's now simulate a disk failure on a node. As you can see, the rebuild process starts immediately. In that backend view, you can identify the actual failed drive and monitor the rebuild process. Meanwhile, all the volumes are online and there is no impact on the clients. Once the rebuild process has completed, the dashboard indicated that all volumes are fully reprotected. Now let's simulate a disk replacement on that node. As you can see, this triggers a rebalance process to spread the data on the new drive. This completes this VxFlex OS demonstration lab. Thank you for watching.